Good morning and warm greetings, dear friends and students. Today I am going to deliver a lecture video on the truss analysis. I have given an introduction part in the previous video, what is called as a perfect stress and what is imperfect stress. In the imperfect stress, there are two types. The first one is deficient truss or a frame. The second one is redundant truss or a frame. And I have given an example also. Now we are going to see a simple problem how to solve the forces in various members of a truss. For an example, I am taking a simple problem of a triangle. So that again exactly on equilateral triangle. You know, equilateral triangle means the input angle in all the three sides is 60 degree. So an equilateral triangle ABC, that is the point A and C are supported by a wall or a column, and the apex of the triangle is equilateral triangle is point B. At the joint B, I am applying a vertical load of 10 kilonewton. So now our aim is to find what are the forces in the member AB, BC and also AC. Only three members, so it is a perfect stress because M is equal to 2J minus 3. Here M is 3 and J is 3 joined, so 3 is equal to 2 into 3 minus 3. So it is, we are getting 3 equal to 3. So it is a perfect stress. Now we are going to solve the member forces, either top chord or inclined chord. So here there is no vertical chord, and the given truss is of 4 meter span and the height of the truss is given as 3 meters. Now I have to find the support reaction. So the support reaction at A and B are, because they are symmetrically loaded truss, so you are getting a total load of 10 kilonewton. So each support will have a vertical reaction of 5 kilonewton upward reaction. Then now I am going to solve by means of method of sections, so method of joints. So here in the method of joints, so you have to use the two condition. The algebraic summation of horizontal force are 0, that is sigma h is equal to 0, and second one is the algebraic summation of the vertical forces are is equal to 0, that is sigma b or sigma f suffix y is equal to 0. Only applying these two conditions, you take joint by joint, you can solve all the member forces. So the member force will be of a tensile nature or compressive nature, and what is the magnitude of the forces, that also you have to find, and we can put in the tabular column also. Okay, now I am taking a joint A. So there are two members. Out of two members AB and AC, the forces are unknown. So there are two equilibrium equations, sigma equal to 0 and sigma h equal to 0. So two unknowns, right? The forces in the member FAB and FAC can be determined. The first equation is FAB, right? I am assuming it's a compressive force because the reaction is upward. So if you are resolving this, sigma equal to 0, that is 5 minus FAB into sine 60 degree is equal to 0. So if you are solving the unknown FAB, you are getting a compressive force of, because it is going towards the joint, compressive force of 5.77 kilonewton. 5.77 kilonewton compressive force. Then next, we can take the joint B or C. So out of which I am taking joint C. So here, in the case of joint C, the force is an unknown. Okay. So in the case of joint A, if you are finding the force the member AC, so that you can see, now resolve horizontally. What will happen? Say there are two members FAB and FAC. So FAB we know 5.77 into cos 60 degree. It is going towards left. I am assuming towards left. That is a compressive force, right? It is going towards left. So the member force in the case of A C is, yeah, we have to put in the opposite direction. That is, it is taking away from the joint. So it is a tensile force. So therefore, right, if you are resolving horizontally, right, so 5.77 into cos 60 degree, which is of minus because going towards left. I am taking going towards right as positive. So here, positive force means what? F A C, right? So if you are is equal to 0, it is nothing but sigma fx is equal to sigma h is equal to 0, that equation. So the only unknown is the force in the member AC. So the force in the member AC, if you are resolving it, you are getting a tensile force of 2.885 kilonewton. So it's a tensile in nature because it is going away from the joint. Similarly, you can find the force in the member BC also, right? It's because it is a symmetrical one, because equilateral triangle, and the reaction at A and B are also 5 kilonewton. So the force in the member BC is also of a compressive nature, which is of 5.77 kilonewton. So it is, right, going towards the joint. So it is 5.77 kilonewton. So this is how you have to find the member force in the case of truss. I have taken a very simple type of stress, that is a equilateral triangle, or you can take a right angle triangle, or you can take box girder, which is of vertical member, horizontal member, and inclined member, right? So first we have to do what is the type of stress, either perfect or imperfect. If it is imperfect, we have to find whether it is a redundant or the deficient frame. If it is a deficient frame, you have to convert as a stable frame. That is very much important. A stable stress. So this is how we have to find. So by applying joint by joint, you can find the right forces in the vertical and horizontal members or inclined members. You can find it. So by applying the boundary, this equilibrium equation, sigma h is equal to 0 and sigma v equal to 0. This is a very simple one in the case of two-dimensional test. Thank you very much for patient listening. வாழ்க வையகம், வாழ்க வளமுடன். And we can see the problem I have worked out, right? So you can see the problem I have worked out. It is in the mirror image, right? If you are putting the mirror, you will get as a correct view.